All right, I'm assuming you've watched the prior videos on how to create a designer experiment and how to run the experiment in the jobs section. And you get the idea of what pills are. We went through the summarized data pill and normalized data pill and pulling in data. Now we're going to build a complete, very simple, but complete machine learning or predictive pipeline with an evaluation. So I'm going to keep this one that we created before and create a new pipeline this time. We'll start over. I'm going to edit and call this one, let's still keep it simple, introduction to pipelines. That'll work. So now that we have that, I want to still use the insurance data set that we had before. So I'm going to click back here on data, click and drag that in. And this time we're going to, let's see, I'll go to component. And because it's quicker, I'm just going to search for pills one at a time. First of all, I want you to grab the select columns pill. So here we go, select columns in dataset. That's the one we want. For now, you're going to wonder why we used it, because I don't want to filter. We use this pill to filter out columns that we don't want and don't need. We do that by, you'll see here in the parameters, it just has a select columns option. I can double click on it and I'm going to tell it edit column and say that we currently want all columns. I'm going to add all and save. So there's no point to this if we're adding all columns, but the idea is when we go through and are building machine learning models or predictive models is that we'll peel out and remove features one at a time or with some sort of methodology. There's a lot of them until we get the most parsimonious, or that we want the simplest model possible that has the best and most accurate prediction possible. Because we'll use this in the future, I just always have one in here, at least right here, even though we're not necessarily going to need it for this example. But I just want you to see how it works. For now, since we've selected all columns, it's simply going to pass everything through. Okay, the next pill we want is the split data pill. Now, if you're watching this video as part of one of my books, then there's a good chance that this will be new to you if you're first time in learning machine learning or predictive modeling. So when we were going through linear regression in Excel, we trained our model with all the features in the insurance data set. That's common with academic research, or if we have a data set that is the entire population. Anyway, typically we'll do something called split the data, which we haven't done before. The idea is we're going to divide the number of rows, not the columns, but the rows, into a testing set and a training set. So the training set is going to come out the left side. Well, I guess really it can come out either side we choose. If you look at these, it just says results data set 1 and 2. But the idea is that the training set will be used to train the model weights. And I'm not going to go into details on those. I'm assuming you have a background already because you've either learned it on your own or you're taking this as part of my class and you understand what regression coefficients are. But the idea is we'll train a regression model with one data set, and then on the other data set, we'll use that to test the model and see how accurate our predictions are. Now, why would we do that? Well, it reduces, doesn't eliminate, but reduces the likelihood of overfitting a model because it helps us to replicate the actual true environment where we might train a predictive model with one set of people, but then we want to deploy it on an entirely different set of people. So, for example, let's say with this insurance data set, we want to come up with a prediction of how much potential customers will cost us. Every time we add them to an insurance plan, we're going to predict their insurance costs. Well, if we run a model with all of our past customers, there's a likelihood that those past customers will not perfectly represent our future customers. So let's say we were to train a model and get a 70% R squared. We think, okay, that's a decent R squared. But then when we get new customers, the actual predictions represent more of a 60% R squared for those new customers. Well, why wasn't it as good as we thought it was? Why wasn't it 70%? That's because of model drift. The population that we're predicting for always drifts or changes somewhat from the original population that we trained on. Well, if we want to get a better idea of what that might look like in practice, we can kind of replicate that by splitting the data into two sets and training it on separate data from the data we use to make a prediction for, to see if, to maybe get a more realistic estimate of what our actual fit will be. Well, what should the proportion be? 50-50? If you have a lot of data, I would say yes, make it 50-50. If you have less data, then you got to decide, well, what's more important? Would I rather have more accuracy in my training results or in my testing results? Typically, we want more accuracy in the training results because that's what we use to make the predictions. If I get a bad estimate of R squared, that's not as hurtful to my company's bottom line as if I get a bad estimate on the actual prediction. So generally, we'll put something higher on the training side. So if I put a 0.7 here, that means it's going to put 70% of the rows coming out of this side, 30% of the rows coming out of this side. Now, it doesn't matter which one I use for training and testing. I just got to remember which is which. So I could have just as easily made it 30% and reversed which outputs I use. But in general, let's just keep it simple. We're going to say, yes, randomize the split. Random seed of 0 means that every time this experiment runs, it will grab a different 70% and put it out the training side. Well, during development, when we're trying to compare algorithms, which we'll do later, where we're trying to compare different models that have different algorithms or different sets of features, we do want a random split, but we want the same random split every time so that if we get different results, it's only due to the change in algorithm or the change in features and not due to the fact that we just happened to get a different set of 70% that was easier to predict or something. So anyway, putting in a number here, any number you want, other than 0, will force it to use a random but the same random split every time. So that's a good practice when we're in the development mode here. All right, so now if we run this, in fact, I'm just going to go ahead and run this now so that you can see how this works. I'm going to configure and submit. No, we're going to make a new experiment this time so we can keep track of things. Introduction to pipelines. I will, however, put all of my runs in this same experiment right now anyway. Okay, next, no inputs and outputs. Select our compute cluster, oh sorry, our compute instance. Still running, there it is, same blob, all good. Next, submit. Okay, let's make sure this goes through. It's currently validating, making sure that this all makes sense. Okay, I'm not going to click View Details because it opens up a new window. Instead, I'm just going to click directly here on Jobs. Notice how, looks like I capitalized that I. Oh well. Intro to pipelines, running. Great, it just shows me just that one. Interesting. Anyway. All right, I'll run on this, click on this, let this finish running, and I'll pause. All right, that wasn't too bad. Honestly, I've used this tool for a few years now, and earlier versions definitely took longer than this one did. I'm curious as to what the total time was now. Let's see. 54 seconds. Huh? Not bad. Anyway. All right, so let's see what this did. Select columns, again, just to show you what this did. All it did was simply pass through. This is a way of reducing down the columns that I have in my data set. But I didn't reduce it all. I told it to pass through all of the columns. Okay, split data. I have two options now. I can preview the results data set 1 and 2. I'm going to go ahead and do both. And it'll pull up both of them right here. All right, so 1, same columns in both of them, right? Here's the full and complete data set we got from the select columns and data set pill. But here, it split up the rows to where in one side I have 937, the other side I have 401. So now I have this data set split into 2, ready to keep going. All right, I'm going to leave this, go back to the designer, and let's continue our machine learning pipeline. So next, now that I have the split data, I want to actually designate what the label and the features are. Now, if you remember in Excel, we did that with the, there's a tool. In fact, maybe I can even pull this up and remind you. Let me open Excel here and grab, I'll just grab any data set. Here's one that I've been using recently. Oh, that's trying to open. Here it is. So if I wanted to create a predictive model on this data set, you might remember that we'd go to data. Oh, sorry, I have to go up here on top. Data. No, sorry, tools. And then I have to go to Excel add-ins. Looks like I don't have it. Oh, no, I do have it on this one. Oh, sorry, right over here, data analysis. Analysis tools. No, okay, right here. I'm still getting used to my Mac. All right. So before, you might remember, we'd go to this regression, we'd hit OK, and then this is where we'd specify some Y column and a set of X's. I just want you to see that's exactly what we're about to do next with a tool, with a pill called the train model pill. So click and drag this one in here. I'm going to put it right about there because this one has two inputs, as you'll see. And this input says it wants a data set. Which one should we take? Well, we want the training one here on the left side. So this is going to be used to train the model. And what does it want here? It says untrained model. What does that mean? Well, it's looking for an algorithm. Back when we were in Excel, we never selected an algorithm here either. We just specified a Y and an X, and we knew that this was going to use the linear regression algorithm. Well, now that we're using a much higher end tool, we're going to have a lot of options. Linear regression is one of many algorithms we can choose from. What I want to do is show you all of them. Come here to machine learning algorithms, and notice I've got here regression. I've got 6 options. Boosted decision tree, there's linear regression. These are, the regression algorithms are the ones we use to predict numbers. Clustering, we may or may not cover this in this course, or it might have been covered earlier in the book when you learned about Tableau. And then classification, we use these to predict categories. It could be predicting multiple categories, or it could be predicting 2 categories, 2 classes. Anyway, we'll get into more of that later. For now, I just want you to grab linear regression, because that's what we were used to. Let's see if I can, there we go. Oh, that's nice. Okay, linear regression, and I'm going to connect the dot from here to here. So this is one other way that it's different from Excel, is the split data pill. We didn't do that before, and we have to specify linear regression. We didn't do that before. It was just assumed. But on the train model pill, what we're doing here is specifying the X and the Y's, like we did in Excel. So double click on it, and it says, what's your label column? So all we have to do is pick the one column. So it says select a single column, column name. If I click on this, oh, that's interesting. This is new from the last time I used it. Anyway, we just type in the column name, charges. There we go. It would have been nice if it had given us a list. Old version used to do that. Oh, that's all right. Charges is the name of our label. If you're not sure, you just have to go back to your insurance data set and you can preview the data and take a look. But by specifying charges as the label, it automatically assumes that every other feature coming through here, every other column is going to be a feature. So if I right click, I can only preview data on this insurance. So that means all of these other 6, because they all got passed through here and through here, they're all going to be included as features. Charges will be the label. All right, so that's what this pill does. Let's go ahead and run this one. So I'm going to configure and submit. Select existing. Yep, perfect. Oh, it stopped my instance after an hour. This happens when you're working because we set it to automatically turn off once an hour, except I thought it would only do it if it was... I'm going to have to... next, it's going to give me a problem because it's currently stopped. Or maybe it'll auto turn on. Let's see what it does here. Configure and submit. No, it won't even let me go because it's turned off. Oh, that's fine. So I'm going to close it. I want this to save though. I'm going to turn auto save on so I don't have to keep saving it. Come back here to compute. Oh, I don't want to lose those. Oh, save right there. There we go. All right, back here to compute. Start it up again. If this happens to you, just click on it. Start. Okay, let's start it back up. Back to designer. Intro. And I realized while I was waiting for my compute instance to spin up that there's one more thing that is new in this version. When we were back here in train model, double click on this again, and we were selecting the label that we wanted to predict. They added this, didn't used to be in here, model explanations. Go ahead and set this to true. We want that so that we can look at the outputs and the trained model weights. So with that set to true, now let's go to configure and submit. Make sure, yep, let's overwrite that introduction to pipelines. Yep, we got an instance running, perfect. Let's go ahead and submit this thing. Should take about a minute, minute and a half to run. But I'll wait, I'll head over to jobs. I'll go ahead and just open it while it's running while we're waiting for it to finish here. Oh, by the way, if you have whatever one you might have, I have 3 here because I was running one during the break. If you only have 2, just click on whatever the most recent one is. So they're in order here, as you can tell. There we go. Oh, and it's almost there. The nice thing is, like I mentioned before, it caches the results from prior runs. Oh, I didn't even have to wait. That was pretty quick. So let's right-click on this one, preview data, trained model, and we should now, although I might have to find it, have some model results, some scored model results. So let's see here. All right, I found it. They've moved things around since I used this last. So it's not here in this preview. I'm going to, there might be another way to get to it, but I'm going to go back to jobs. I found it here. Go into introduction of pipelines. I'm going to break this one out, and then here on train model, I'm going to click on that, and it gives me right here explanations preview. There we go. What we're getting here is an explanation of which features of the feature importance, or this, in other words, the coefficients. So it calls it feature importance. I'm guessing, though, that based on a linear regression, they're simply using the coefficient weights to determine or explain which one of them are affecting charges the most. So they only have the first, top 4 features. We can expand it here to include every feature. So we can see male or female doesn't matter at all. Very little effective. Region, children. We kind of have a natural, it's really just these top 3. Yeah, maybe a little bit children and region, but I would probably eliminate sex entirely from the list of features. So linear regression is one of its advantages is we do get these coefficients that show us importance. But as we'll learn later on this course, there's other metrics to get importance for all of the different algorithms. But let's see what we've got here. Oh, dependence plots. That's nice. Age, all data. Let's see what that does for us. Bar, box. Oh, that's nice. We've got some good new features here. Oh, I got to click on select a feature. For some reason, it's not generating that dependence plot. Well, they're constantly working on these all the time. Let's see what we get here out of fairness. Oh, we'll come back to this. I remember reading about this one. Anyway, so this is what train model does for us. Gives us a chance to see what matters the most. Oh, and we've got some others here. Model performance. Some of these metrics, there we go. We didn't even need, this is based on, so right here, the R squared, you've learned about these before, MAE. These values are based on the training data set. So while that's nice that we have this, we split the data so that we could get a different set of evaluations based on the testing data set. And we're going to trust those more than this. And typically the testing data set will often have something a bit lower than this training data set. But at least it gives us a nice prediction here, including some quartiles. That's nice. Dataset Explorer. Let's see here. Aggregate individual. Let's set age by, oh, that's cool. Yeah, this is a much, they've really put a lot into this tool. A lot nicer than the ML Studio Classic in a lot of ways. All right, let's go back. Designer, pipelines, we're not done yet. So the standard machine learning path is to split, train, and then score and evaluate. So now that we've got a trained model, we need to create a set of predictions for this testing data set and then evaluate how close those predictions are to the actual data. So to do that, we want another pill called score model, not data. There it is, score model. I'm going to put it right here. As you'll see, because it has 2 inputs, it wants a trained model. Perfect. You can tell exactly where that's going to come from. So just like we did in Excel, it's going to take the coefficient feature weights and the y-intercept out of this trained model pill. And then it wants this data set, the testing data set, that hold out 30%. And it's going to make predictions for that 30%. And rather than run this one right now, I'm going to go ahead and grab evaluate model right here and pull score data set into the left side. This data set will have both the actual charges from here and the scored predicted charges from here, and it will compare them as it comes up with an R squared, RMSE, MAE, and all that. So let's go ahead and run this model one last time. Configure and submit. Looks good. Submit. Head over here to jobs. And, oh, did it not submit? Let me head back to designer. Maybe I was just too quick. Maybe it's there now. Let's try again. There it is, number 5. Just had to refresh it. All right, running these last two. All right, looks like it's all done. Let's take a look at the score model first. Append, okay, I forgot to check these parameters before I put them in. Append score column to the output, true. That was defaulted to true. Let me show you what that did here. So as we preview this data, we now have both the actual charges and then the predicted charges for the data set. And again, this is for just that 30% holdout. We can see, here's what's interesting. Again, you might remember this from our earlier chapters because charges was so skewed. Notice how the predicted charges are trying to follow a more normal curve. That's because linear regression has that assumption that the data follows a normal Bell distribution. Well, when it doesn't, when the actual data doesn't follow that, that means that our predictions are going to be more off at the extremes. So again, we have values, fewer values here and more values up here than are represented in the actual data. Anyway, that's just a side note. So score data set generates our predictions. That's what we're doing all this for in the first place, is to get predicted values. Evaluate model helps us understand how good the results are going to be. So here's where we get MAE, RMSE. So this is our range, our more conservative, our more liberal estimate of error. Liberal meaning that it's lower. It thinks it's going to be good. This is something we trust more when the assumptions of linearity are met. When they're not, we might trust this one a little bit more. The RMSE, it's a little bit more conservative, meaning it assumes more error. Anyway, let's take a look at, if I right arrow over, R squared here, just like I said, is likely going to be a bit lower. So 74.4% as opposed to, go back to our train model. Man, there's got to be a quicker way to get to this. What was it? Oh, here we go. If I double click train model, that's faster than what I did before. Explanations. No? Somehow I've lost it now. I didn't like it from this view. Evidently, I've got to go all the way back to jobs. Let's see if I can get it from this view. Train model. No, because this was a recycled, that's why. It wants me to go to the one from the prior run, I guess. Let's see if that works. Train model explanations. Yeah, this one works. Here we go. Model performance. Yeah, 75.3%. So remember, this one, when you come up with evaluation metrics on the same data you train on, you often overinflate your fit metrics. You think it's better than it is. R squared's higher. Mean absolute error is 41.97 here. Well, if we go back to the other one, it's going to be something higher than 41.97 is my guess. Sure enough, there, 42.11. Yep. So a more conservative, higher number when we actually based our evaluation on a testing split, training testing split. That's why we do that split, is to get a more accurate. It doesn't necessarily improve the actual prediction. It just gives us a more accurate analysis of the prediction and helps us prevent overfitting. Anyway, all right. I know that was a long video, 25 minutes, but that's our introduction to modeling in a machine learning pipeline in the Azure Designer.